Hi student, myself D.K. Narale, working as assistant professor in Gopal Krishna Gokhale College, Kolhapur. Today going to discuss the nanotechnology chemistry paper number 16 industrial chemistry. Last lecture discussed about these 2 points. First, the introduction of nanotechnology, and second point is optical properties. In this video, we will discuss the synthetic route of nanoparticles, that is top down and bottom up approaches, and second is the synthesis method. Total 5 methods: sol gel method, precipitation, chemical reduction method, chemical vapor deposition, hydrothermal and electro deposition discussed in this video. Last lecture these the study points all studies. Approaches for synthesis of nanomaterial. First, top down, two approaches. First, top down, and second is bottom up approach. Breaking bulk material top to nanoparticle, top down and bottom up approach. In top down method, bulk material breaking down into more basic building blocks. This bulk material is breaking down to form a powder or building blocks. Frequently use a chemical or thermal method. These synthesis of nanoparticle by chemical or thermal method, that is physical methods. Bottom up approach, these atoms then the converge into cluster and then nanoparticle. Bottom up approaches building complexes system by combining simple atomic level component to form a cluster, and then the calcine then form a nanoparticles. The top-down approach's advantages: large scale production, deposition over large substrate is possible. Second, chemical purification is not required. Disadvantages of the top-down approaches: yields broad size distribution, that is the 10 to 1000 nanometer, varied particle shape or geometry, control over deposition parameter is difficult to achieve. Preparation of the nanomaterial, the deposition of parameter is difficult for to achieve the size of the particle. Impurities, that is stresses, defects and imperfection get introduced. Expensive technique. Second, bottom up approaches advantages: ultra fine nanoparticle, nanocell, nanotube can be prepared. That is the chemical method. Deposition parameter can be controlled. Narrow size distribution is possible, 1 to 20 nanometer, and cheaper technique. Disadvantages of bottom up approaches: large scale production is difficult and chemical purification of nanoparticle is required. Synthesis method of nanoparticle is: first, sol gel method; second, precipitation, chemical reduction method, chemical vapor deposition method, hydrothermal method, electro deposition method. First, sol gel method. In this method, prepare metal oxide via hydrolysis of precursor, usually alkoxide, in alcoholic solution, resulting in the corresponding oxohydroxide. Condensation of molecule by giving off water lead to the formation of metal hydroxide, undergoes polymerization by condensation and form dense porous gel. And appropriate drying and calcination heat, that is the heat, calcination means heat, lead to ultra fine porous oxide powder is formed. Schematically representation of metal precursor dissolved in alcoholic solution, then form sol, then dehydration, reduction, then form gel. The water is removed, then form a gel. Rapid drying to form a aerogel, This gel is add a surfactant organic moiety to form a zero gel, and the zero gel calcine to form a dense ceramic materials. Then this sole spinning technique to form a thin film coating, and then this thin film calcine they form a film coating on thin film coating. This sole heated to form a suspension, and then calcination to form a powder. That is the formation of sol gel method to different types of from sole, film coating, powder formation, and dense ceramic materials, and also aerosol. Second, chemical reduction method, reduction by adding the trisodium citrate. Step first, dissolved 0.0 gram silver nitrate AgNO3 in 500 ml water, heating near boiling 95 to 98 degrees Celsius. Then add the reducing agent 1% trisodium citrate solution, that is the 0.1 gram dissolved in 10 ml water, and this trisodium citrate dropwise add to the AgNO3 solution 1 drop by per second. Then for the continue heating 95 to 98 degree near boiling for 15 to 90 minutes. Yellow color indicate the formation of silver nanoparticles. That is the second method. Third is precipitation method. In this technique, metal precursor use, that is a formation of zinc oxide by zinc chloride, zinc sulfate, or zinc nitrate as a salt of the zinc precursor. Precipitating agent, add this salt precipitating agent solution, then addition of precipitation precursor, then form of precipitation, filtering and washing by alcohols and distilled water and alcohol, then form a zinc oxide nanoparticle, calcine, and characterization of the zinc oxide nanoparticle. This is the old technique. Chemical vapor deposition, next method. Chemical vapor deposition may be defined as deposition of solid on the heated surface from chemical reaction in the vapor phase. Next, it belongs to class of vapor transfer process which is atomistic in nature, that is the deposition species are atoms or molecule or combination of these. Such vaporization, sputtering, molecular beam epitaxy, and ion plating. In its simple incretion, CVD, chemical vapor deposition, involves flowing a precursor gas or gases into chamber containing one or more heated object to be coated. Chemical reaction occur on and near hot surface, resulting in the deposition of thin film on the surface of the substrate. This is accompanied by the production of chemical byproduct that are exhausted out of the chamber along with unreacted precursor gases, as would be expected with a large variety of material deposited and the wide range of the applications. There are many variants of CVD. In diagram, one side gas is passed and unwanted byproduct gases is out by next side by the gases chemical byproduct removed. It is done in hot wall reactor and cold wall reactor at total processes to above atmospheric pressure with and without carrier gases, and at temperature typical range from 200 to 1600 degrees Celsius. There are also variety of CVD processes which involve the use of plasmas, ions, photons, laser, hot filaments or combustion reaction to increase deposition rate and lower the deposition temperature. Deposition mechanism, actual one side gas is pass and the deposition on this film and the out of gases is by this side. In the manner in which the film is formed on the surface of CVD is still matter of controversy, and several theories have been advanced to describe the phenomena. Figure 10 shows the 7 mechanical steps that have been hypothesized occur during a vapor deposition process. These steps include transport of reactant gases into the reaction chamber. This reaction chamber, intermediate reactant form reactant gases, diffusion of reactant gases through the gases boundary layer to the substrate, absorption of gases onto the substrate, that is the substrate surface, single or multi-step reaction at the substrate surface, deposition of product gases from the substrate and surface, force exit of product gases from the system. These reactant species, these are the gases byproduct, these solid product, these are the solid product, and advanced intermediate. These are the advanced intermediate on the substrate, and the solid material is deposition on the substrate, that is the film. Hydrothermal method. In this method, mainly solvent is used as a water, and as similar without water is organic solvent used, that is called as a solvothermal. Solvothermal means the solvent, organic solvent is used by this reaction. Hydrothermal synthesis include the various technique of the crystallizing substance from high temperature aqueous solution at high vapor pressure, also termed as a hydrothermal method. Hydrothermal synthesis can be defined as method of the synthesis of single crystal that depend on the solubility of mineral in hot water under high pressure. This is the diagram of the hydrothermal technique. The inner wall is the Teflon, and this is stainless steel cover, stainless steel lid, and the water with the solid reagent, 25 ml Teflon cup, stainless steel cell covered. This solution pour in the Teflon and they pack to fit in disc with a screw. Water used as a solventifies the hydrothermal method. Electrochemical deposition. This method is used for deposition of metal ion such as silver, gold, copper, etc. For the electrodeposition of silver nitrate solution is used as a electrolyte. Silver nitrate is used as a electrolyte in this diagram and this type. The reduction of silver ion takes place to deposit silver on platinum cathode surface. This platinum cathode surface. Thank you for listening and watching.